you want to talk about?
No, I'm just looking out there. There's a whole variety. If you look for basically physics, rigid body dynamics, anything to do with dynamics out there, this is a very fertile field in computer gaming right now. It's building kind of modular physics engines that can be used in games. So in some sense, part of the work now is to isolate the physicist from the game. But you work on building your engine, and then we'll take that engine and put it in a game and put, for example, here just bunch of blocks. But you could easily put some very complicated models on top of this that would be beautiful, have lots of great eye candy, that would make things look much nicer on there. I was just looking out there and seeing, there's a couple of examples out there, pretty good, but I don't remember the names. There's a what's the physics engine on the card?
Geophysics. It's spelled P-H-Y-X.
H-Y-X?
Yes.
How do you spell it? Agea?
Agea, yeah.
A-G-E-A? It's NVIDIA?
Yeah, it's yeah, A-G-E-I, yeah, H-Y-S-S. That's what happens when you bastardize
Let's see if we've got here we go. Let's look at this one. This one's good.
Yeah.
So why is this interesting that we're talking about this thing? So how many people know what NVIDIA is? It's a company that builds cards that you plug into your PC. What does it do? Well, it helps make pretty pictures. What it does is it takes objects, essentially represented by collections of polygons with textures on them, and draws them insanely fast. The metric is the more polygons it can draw, the better. Many of the environments you look at have hundreds of thousands of polygons. It can do millions of polygons a second. 10 million, 20 million. Travis, what's the current limit right now for cards?
About a billion.
A billion? Yeah. So what it can do is it can do environments that are incredibly complex in real time. It's actually been probably one of the things that's actually driven the evolution of hardware the most, because why do people pay all this money to pay $200 or $300 to have a special card to do graphics? Well, they want their games to look beautiful. So what's happened is NVIDIA, which is in charge of making these cards, came up with a really good idea. They said, well, we don't want things just to look good, we want them to move in interesting ways. And so what they've done is they've actually released now a physics engine on a card. So just like we can do all the drawing and rendering on a card, NVIDIA's released an engine, a chip, that actually can do this in hardware. As a result, it can do a lot more work. So this is a demonstration of it doing some kind of fluid simulation. Now, I wasn't watching on this, but my guess is what it's doing is it's treating all of the fluid as a bunch of little spheres that are moving around, and it then renders them as if it's a single fluid on top of it. So here it looks like to me it's pouring some kind of liquid through a transparent tube. Actually, give me a second. I want to watch this because I don't think if I've seen this or not. Let me watch it too, and I'll make a few comments.
After this, we're gonna you guys can have a seat and we can drill you with questions.
Okay, so how's it doing this? Well, it's treating that fluid as a bunch of little dots. And it's figuring out how the dots move around, and then instead of drawing them as dots, it draws it as some kind of surface that contains the dots. So as a result, we get something that looks kind of interesting. Now, where does physics come into play? Well, how do the dots interact? What laws do we use to make them look like they're fluid? That's a place where physics, the laws that you basically things like, for example, Navier-Stokes, can help you to derive rules that lead to better looking fluids. And so that's a little bit of what's going on.
So would you guys like to answer some
Just a question. Not that you necessarily know much about this engine, but
Yeah.
I wonder if part of it is everything is interacting with everything.
Well, that's actually a good question. So how many of you here do like astronomical simulations in body problems? Anybody? So you have the laws of gravity. So the differential equations, and gravity goes down 1 over r squared. So in theory, if you're simulating the motion of all the bodies in the universe, everything influences everything else. So it's a terrible n squared problem. To do one time step, you have to do n squared computations for everything interacting. But what happens is, in practice, people don't do that. What they observe is that you can cluster. Think about stars. Okay? We have the sun. We have the solar system. We have our galaxy. We have, I guess, what is it? What's it called? Clusters of galaxies. And you have the universe. So there's a hierarchy there. So what people do is they build hierarchical methods that cluster things together. And they treat a cluster as a single entity in the simulation. So you can imagine there's a tree. The universe is here, and then we have clusters of galaxies. Each one of those is comprised of a galaxy. Those are comprised of solar systems. Solar systems are comprised of planets. And so it organizes the computation in a way that we don't do all the planets with respect to each other when we're modeling how galaxies evolve. We simulate and approximate at an appropriate level. And that appropriate level is a function of how much computation time we have and how realistic we want. So the answer is, my guess is that all of these use some kind of geometric clustering method to basically cluster things that are nearby together and use a summary on it.
So, are we going to talk about work?
No, well, it's gonna. I don't think it's going to load before. It takes it a long time to load it. I didn't remember to load it before we came. So, if it's done before we go, that's fine.
So, go ahead.
Oh, I was going to ask, are a lot of these methods like trade secrets? Like, they don't want, like NVIDIA doesn't want people to know how they
Travis,
do that, right?
Oh, you want to try to answer that?
Well, I think the hardware itself is usually basic, but the way how they implement it is usually in the hardware, but the libraries or the SDK is always in the hardware. And there are a lot of other software alternatives that are definitely open source.
So I think one of NVIDIA's major goals, Joe alluded to it, but just to create technology that people can just use for their own purposes. I've tried to implement a number of physics simulations or physics engines, and my experience has led me just to say, all right, I'll use NVIDIA's package or I'll use a pre-existing engine. So people, NVIDIA, I don't think they'll have to worry about someone trying to compete against them as far as creating, aside from probably ATI, but no one's really going to compete against them. Most people are just going to use what they have. So.